Well, in our previous class, we have seen different the structure of antibody we have seen, and we are also seeing the different types of immunoglobulins. In today's talk, we'll talk because all these topics comes under acquired immunity. The next topic in acquired immunity is nothing but the components of acquired immunity. And I hope you all very well know what is acquired immunity. The immunity that is being acquired by an individual after his birth, after getting exposed to or getting used to when he encounters with the different types of antigens in his daily life due to his various activities. When he come across with different types of antigens, the antibodies, specific antibodies are produced in his body. Such a type of immunity is what is referred as acquired immunity. We are discussing different topics, subtopics in acquired immunity. Now we will be discussing about the components of acquired immunity. Components of acquired immunity. In this acquired immunity, we have to discuss. There are two types of cells we will discuss today. Right? One is B lymphocytes and another is T lymphocytes. Right? One is B lymphocytes. B lymphocytes. Then we discuss about T lymphocytes. T lymphocytes. Now, basically, what do you mean by B? B stands for in mammals. In human beings, in mammals, B stands for bone marrow. B stands for bone marrow. Whereas T stands for thymus gland. Thymus gland. When we started this chapter in the beginning, when we started immunity, I told you there are lymphoid organs. Immune system consists of lymphoid organs, lymphatic vessels, lymphatic nodes, lymph glands, lymph nodes, all those things. So we have discussed also primary lymphatic glands and secondary lymphatic glands. Both these comes under primary lymphatic glands rather. One is bone marrow, which is a major primary lymphatic organ. What is a lymphatic organ? The organ that produces lymphocytes. Thymus gland, which is found situated behind our sternum bone. In our first year, I have told you the sternum bone. The breastbone also is known as breastbone, which joins the two rib cages, the rib sets. That bone is known as sternum bone. Behind the sternum bone, very close to heart, there is a small gland known as thymus gland. As the age of the person increases, the thymus gland decreases in size. As the individual grows up, right? The size of the thymus gland will decrease. That is inversely proportional to his age. At around the age of 40 years, this thymus gland totally disappears. That's why after 40 years, most of the people are sensitive to diseases, disorders and infections, and because the lymphatic organs will disappear, immune system will not be so strong. So that's why that thymus gland. So now in both these lymphatic organs, they help in the production of differentiation of lymphatic cells or lymph cells. So whichever the cells that come from bone marrow, in bone marrow also red bone marrow, because you know that red bone marrow is a factory of cells. All the blood cells are formed in the red bone marrow, because in the yellow bone marrow fat cells are stored, adipose tissue is stored. So here in the red bone marrow, B lymphocytes are produced. These B lymphocytes get differentiated to plasma cells. These plasma cells produce specific antibodies against the antigens. Similarly, some of these cells, for example, all the cells, in the bone marrow, cells are produced. Stem cells are also produced in the bone marrow. So some cells, they get migrated from bone marrow. Certain cells are produced in thymus gland, they migrate to thymus gland. From in thymus gland, they undergo development, they undergo proliferation, they undergo activation, and they undergo differentiation of all these processes that takes place in the thymus gland. From the thymus gland, T cells are released. From the bone marrow, B cells are released. Bone marrow cells, the plasma cells produce antibodies. So similarly, cells are the B cells. Whereas when you talk about B cells, B lymphocytes, in case of birds, in apes, B stands for bursa of fabricus. of fabrica or bursa fabricus. There will be a small gland in the tail region of these birds. That gland produces oil, that secretes oil, In that oil, right, you come across antibodies and specific things. So that prevents, that helps in the immune system in case of birds. B stands for bursa of fabricus. Whereas in case of mammals, you all know that mammalian bone has a system, bone marrow. So in the bone marrow, B cells are formed. These B cells, right, undergo proliferation to get differentiated into plasma cells. These plasma cells produce specific antibodies against antigens. Right? Such cells are known as B cells. Right? Then the cells that undergo differentiation, proliferation, activation, and they are released in the blood, and such cells are known as T cells, thymus gland cells, or T lymphocytes. They are known as T lymphocytes. The word itself says lympho, the lymph or the blood circulatory system, then cytes, cells, lymphocytes. Now, the main function of B lymphocytes is to produce specific antibodies when they become plasma cells. Whereas, in case of, you have different types of B cells also, that's not there in your syllabus in your second year. When you go to first year medical, there you study under medical physiology or immunology you study under medical microbiology. But we have to discuss, as per your syllabus, we will be discussing about different types of T cells here. There are 4 types of T cells. 6 types of T cells are there, but we will be discussing about 4 types of T cells here. That is T stands for thymus, T lymphocytes, T killer cells, T killer cells, T helper cells, right? T helper cells. Then T memory cells, Then T suppressor cells. So all these cells, as the name suggests, T killer cells, fine. These cells kills other cells. Which cells? Antigens, pathogens, fine, or any other foreign particles which enter into the body, into the blood circulatory system. There. Through cell-mediated immunity, killer cells, they kill. How they kill? By producing cytolysins or cytotoxins, or by perforins. They form perforations, they puncture the cell wall, they rupture the cell wall, they damage the cell wall of the pathogen, of the antigen. Such chemicals released by T killer cells are known as perforins, as the name suggests. Perforins, right? Porous nature, porifera, same name. Perforins, chemicals which forms the pores in the cell wall of the antigens. Cytotoxins, they are the toxins against those pathogenic cells, against those bacterial cells, foreign cells. Cytolysins, again lysine which digests, which dissolves, which damages the cell wall of the pathogen, cell wall of the bacteria. They lyse, they dissolve that, they inactivate that, they kill that. So these are the different types of proteins produced by T killer cells. T killer cell is a type of T lymphocytes. Is one type of T lymphocyte. They kill the cells, which cells? Harmful cells, pathogenic cells, antigens, bacterial cells, other viral particles also, by producing cytolysins. Cytotoxins are perforins. In the NEET, they may ask you this about these chemicals. Right? Helper, as the name suggests, these cells help the cells. Help which cells? Right? They help the B cells. They help B lymphocytes. What for? To produce specific antibodies. For specific immunoglobulins. T helper cells, as the name suggests, they help in the production of, secretion of, or proliferation of B lymphocytes. This type of T cells, T lymphocytes, help in the production of specific antibodies by B cells or by plasma cells. Such cells are known as T helper cells. Right? Next type of cells is known as memory cells. This is very important. As far as immunology is concerned, memory cells are very much important. In B cells also we have the type of memory cells. That much detail is not there. You may get confused also when we talk about that. So B cells here, B cells, T memory cells. What cells? T memory cells. These cells keep the memory. They remember. They keep the memory of the pathogens, the nature of the antigen, the chemical nature of the antigen, the structure of the antigen, the chemical nature, the chemical composition of the antigen, the shape of the antigen, the molecular weight of the antigen. They remember. In the first encounter, what do you mean by that? When a person is getting infected for the first time, our immune system takes a little more time to react to that, to produce specific antibodies against that. Why? Because it's the first encounter, first time these antigens have attacked the human body. Whereas when they attack for the first time, these memory cells remember them. Remember what is the nature of these antigen, what is the shape, what is the structure, what is the molecular weight, what is the chemical composition. Then when in the second encounter, when these cells, when these pathogens enter into the human body for the second time, for the next time, they remember. The memory cells give signal to the B lymphocytes to produce what? Specific immunoglobulins or specific antibodies against that. So here in the second encounter or second attack of the pathogen, same pathogen, the immune system will react very quickly, immediately. Specific antibodies are produced very fast. Immune responses will start, immune reactions will start, and antibody complex formation will start. Why? Because these cells are attacked for the second time. This is the basic concept of vaccination. We have to talk about vaccination in our next upcoming classes. So for the whole concept of vaccination depends on the memory cells, because these T memory cells are the cells which are responsible for recognizing, identifying the antigens. As soon as they identify them, right? They stimulate the B cells to produce specific antibodies, so that their effect will be stopped, the pathogenicity will be stopped, the infection will be reduced. So such cells are memory cells. They are very important cells as far as the immune system is concerned. Next, right? As so far you are seeing T killer cells killing the cells, helper cells helping the B cells to produce antibodies to kill the cells. Memory cells are also stimulating the B cells. Now there should be somebody to control all these functions of the immune system. Hence the word suppress, which slows down, which cross-checks, which puts the humps like in a highway. Right? You are going, the function immune systems are killing all the cells. We need some cells. We need the bacteria, the helpful bacteria. So the body, the immune system should be able to differentiate which are the important cells, which are the pathogenic cells, which are the body flora, normal body flora. What do you mean by that? The cells, the bacteria which are required by the body to carry out different biochemical reactions, to carry out physiological functions of the body. For digestion also we need a lot of bacteria, because they have to produce enzymes. And for our normal body, in our normal body also we have so many microorganisms which are beneficial to us in our intestine, in our digestive system, in our reproductive system. So certain bacteria, certain cells are there which are required. These cells should not be harmed. These cells should not be killed by our immune system. To check the function of immune system, whether the immune system is functioning correctly, promptly, perfectly, to check that, to put the brakes, right? There are some certain cells known as suppressor cells. That's why they are named as suppress, because they cross-check the function of immune system, immune cells. They suppress their function. Don't keep killing all the cells. Some of the cells are required, some of the cells are beneficial, some bacteria are required by the body, some cells are required by the body, right? So here these cells checks the function of all these cells. They cross-check the function of these cells, they suppress the function of immune system, they slow down the function of immune system, they put brakes to the immune system, they give hints to the immune system not to kill the own cells. But yet there is a concept known as autoimmunity. In our upcoming topic, there is autoimmunity is there. What happens there? Our own cells, immune system kills our own normal required cells, which is not a correct action. So to cross-check all those things, we have very important type of cells known as suppressor cells. Their activity, their function is to suppress the other cells. Now, I hope you have understood the difference between B lymphocytes from bone marrow. They are known as plasma cells produce antibodies for their function. These are the different types of T lymphocytes that proliferated from Thymus gland is also a primary lymphatic organ. Bone marrow is also a primary lymphatic organ. Apart from this, in the last topic we discussed secondary lymphatic organ. In the previous class, in the very beginning of the immunology, also I have told you, like tonsils, vermiform appendix, right, Peyer's patches, all these acts as secondary lymphatic organs, right? So here now it's clear. Now we'll talk about the other components of the acquired immunity. Based on these two types of cells, we can have two different types of immunities, which are very important, right? One is known as cell mediated immunity. Cell mediated. Now this difference can be asked in your final exam also, right? One is known as cell mediated immunity. The other is known as humoral immunity, or it is also known as humoral immunity, clear? Or it is known as, right, cell mediated immunity, humoral immunity, right? Clear? This humoral immunity, right, is brought about by B lymphocytes, whereas cell mediated immunity is brought about by T lymphocytes. Cell mediated immunity is brought about by T lymphocytes, whereas humoral refers to blood. It's also known as body fluid immunity. Humor refers to body fluids, in particular blood. So in the blood you have antibodies, because the blood also you have antigens. So this immunity is given by, regulated by B lymphocytes, whereas cell mediated immunity is regulated by, formed by T lymphocytes, right? Then the cell mediated immunity shows immunity against transplants, body transplants. For example, in some person, organ transplantation has taken place. In your first year in axillary chapter you have studied, right? Renal transplantation, kidney transplantation you have studied. Some organs are transplanted. In this organs, when the organs are transplanted into one's body, his body identifies this organ as a foreign organ. The organ which don't belong to his own body. This is the very, very important property of immune system, to identify between self and non-self cells. These cells don't belong to his body. This tissue, these cells, this organ has been implanted into him, has been transplanted into him, has been surgically inserted into him. Such organs, such tissues are known as transplants. So in kidney transplantation also, right? In kidney transplantation also, the immunity of the person will be suppressed, will be reduced by giving cyclosporin A. You will study about that in 10th chapter, immunosuppressor agents, right? Trichoderma polysporum produces that. In 10th chapter again we will talk about that, which reduces the immunity of the person. So in the during transplantation surgery, the immunity of the person will be suppressed, so that immunity against that should not be produced. What do you mean by that? For example, to short on this topic, kidney transplantation has been done. So in his body considers this kidney as a foreign organ, as a foreign particle, foreign organ. So it starts producing antibodies, kills that organ, right? So such a thing is known as organ rejection. The concept is known as organ rejection. If organ rejection takes place, again that organ which has been transplanted has to be removed again. So it's not a good thing for the patient. Why organ has been transplanted? Because his own organs are not functional, not working, they are infected, right? They are infected. So surgically other organs like kidney transplantation, for example, to understand. So that immunity will be reduced. So that operation, that surgery will become successful. Whatever the organ has been transplanted in his body should adjust to his body, should get customized to his body, should get adjusted to his body, so that his body should slowly start accepting that organ and the function of that organ. So here, cell-mediated immunity shows immunity against the organ transplants. Then also this shows immunity against all types of pathogens, that is including bacteria, viruses, fungi, protozoans, right, and other etc. all pathogens, towards all pathogens, immunity will be produced, immunity will be exhibited in the body from T cells or cell-mediated immunity. It shows immunity against all pathogens. Now here, this don't show immunity or don't produce immunity against transplants, right? Whereas here it shows against transplants. Here it shows immunity against only bacteria and viruses. Whenever the pathogenic bacteria or the viruses enter into the body, this humoral immunity gets activated first. This immunity also acts against bacteria, viruses, fungi, protozoans, all other allergens, right? Other pathogens, other infectious agents, helminthic agents against different spores, different eggs, right? Protozoans, etc. Whereas in case of human immunity acts only against bacteria and against viruses, right? Now, this type of immunity also it shows the immunity against cancers. What do you mean by that? If any of the tissue or organ dividing, growing, in the same chapter we have discussed cancer, we will talk about that. In cancers, right? When because of the carcinogenic nature, any cell or any tissue, any organ dividing more than the required, right? Or without function, any cells are undergoing cell division, it forms a mass of cells known as tumor. So it prevents the formation of tumors. It suppresses the formation of tumors, right? So that it shows immunity against cancer. If any of the organ is simply dividing, multiplying, the organ is growing more than the normal range, more than the required, fine. Such concepts leads to cancerous tumors. Tumors are also of two types. One is malignant, other is benign tumor. We'll talk about that. So whenever cancer formation takes place in the body, naturally, normally, immune system shows immunity against that. Whereas here it does not show immunity against cancer. So this is the difference between cell-mediated immunity and the humoral immunity. In our next class, we will be talking about the difference between active immunity and passive immunity. If I talk differences between now only, you may get confused because today we have discussed the differences between B lymphocytes, T lymphocytes, different types of T lymphocytes, different functions of T lymphocytes we have discussed, and we have discussed the cell-mediated immunity and humoral immunity. Now remember, cell-mediated immunity is brought about by T lymphocytes, it is brought about by B lymphocytes. Clear? Then it shows immunity against transplants. It does not show immunity against transplants. It produces immunity. It shows immunity. It helps in the production of antibodies of all the pathogens. Whereas here it is very specific, restricted only to pathogens like bacteria and viruses. And it shows immunity against formation of tumors, formation of cancers. Whereas here it does not show immunity against cancers and tumors. In our next topic, we will be talking about active immunity and passive immunity. Very easy, very simple. But in this same session, why I am not discussing about that? You may get confused between the differences: T lymphocytes, B lymphocytes, then cell-mediated immunity and humoral immunity. In our next class, we will talk about active immunity, passive immunity. Then we will talk about vaccination, very important topic, autoimmunity. Fine. Okay. Do take very good care of yourself. Subscribe to channel. Fine. Watch the class repeatedly. Watch the class repeatedly. Watch the class repeatedly. Make your own notes, class notes. Fine. Do take very good care of yourself. Fine. Subscribe the channel. Watch the class repeatedly. Take the care of your family members, and make your own notes. God bless you all. Take care. Good night.